Alright, super important particle motion FRQ here. You guys need to get this stuff down for the AP exam. This one's not a bad FRQ. In fact, this is one of the FRQs that you're going to want to get because it's actually quite easy once you start getting the gist of what's going on. So let's get started. So this is question 6 of 2012, and we're given that we have a time interval from 0 to 12, and there's a particle moving along the x-axis. Cool. So we're given velocity. That's awesome. We're given the velocity function, and the particle at position x equals -2 is at time t equals 0. So we're really saying there, what they're really telling us is that x of 0 is -2, and we're going to use that in some way, obviously for part D. And remember, x of t in this case we're calling is position. That's the position function. Okay, so part A, let's get started. I'll do part A in blue. So part A is going to be, when is the particle moving to the left? So particle is moving to the left when velocity is negative. So that's what we need to find. We need to find when velocity is negative. So v of t is equal to cosine of pi over 6t. Okay, so we're going to first set this equal to 0. We need to find the critical points and then find between those critical points and outside, what's going on with the sign. So set this equal to 0, and cosine of pi over 6t is equal to 0 when? So when is cosine 0 is the best question to ask here. Cosine is 0 at pi over 2 and 3 pi over 2, in that 2 pi range. So how do we make cosine of pi over 6 into cosine of pi over 2 or 3 pi over 2? You need to multiply it by 3 and 9, right? So t equals 3 and 9 are the solutions. Why? Because cosine of pi over 6 times 3 is cosine of 3 pi over 6, right? Cosine of 3 pi over 6, and this is the same thing as cosine of pi over 2. In the same time, it's cosine of 9 pi over 6 for the time when t is equal to 9. And this just turns into cosine of 3 pi over 2, and both of these are equal to 0, and so those are critical points. Okay? So these are our critical points. Now let's make a sign chart to find out when, on what intervals things are increasing or decreasing. So we have 3, we have 9. And then obviously we have a maximum of 12. Can't go past 12. So let's plug in something to the left of 3. Well, let's plug in 0. Cosine of 0 is 1, so this entire interval is going to be positive. Let's plug in any number from 3 to 9 now to find what about this interval. So let's plug in 4. Cosine of 4 pi over 6 is the same as cosine of 2 pi over 3. This is an angle in the second quadrant where cosine is negative. So this is automatically going to be negative, and for 9 to 12, let's plug in 12 actually. Let's actually plug in 12. It's going to be cosine of 12 pi over 6, which is cosine of 2 pi, and that's positive. That's just 1. So on this interval, so the answer to this part is going to be when velocity is negative. We just did a sign chart. And yeah, so from time t equals 3 to 9, particle is moving left. Okay, so awesome. That's our first answer. And you can, word that however you want. Just make sure you state the answer. And don't give an over-explanation because I never asked you to explain. If they ask you to explain, then you have to say that's when velocity is negative. But yeah, all right. Part B. So we're going to do this in red, and we can actually do this one right here. So write but do not evaluate a integral expression that gives the total distance traveled by the particle from time t equals 0 to time t equals 6. Awesome. So all we're going to do here is write an integral expression. Now, look at what they're asking. They're asking for total distance. So obviously integrating velocity is the most obvious choice here, right? It's super obvious. We're looking for position or distance. We need to integrate something because integration of velocity gives us distance. But just integrating velocity on a time interval will give you displacement, because remember, the particle is moving left. So what I'm saying is, imagine, you go a certain distance, and then you go back a little bit. That's when velocity is negative, and then you go a little bit more. So from start to finish, you got to here. Now in the same case, this is only saying your displacement, because what about the distance you traveled here? So how do we account for that? We need to say, instead of that, we go here, so we go a certain distance, and even when velocity is negative, we're traveling a certain distance, and then we're traveling. So this distance right here that we traveled is greater, right, than this one right here. And so how do we account for that? Well, we need to take the absolute value of velocity and then integrate that. So this is actually going to be the integral from 0 to 6 of the absolute value of v of t dt, because we need to ensure that anytime in case velocity is negative, we need to make sure that that distance is accounted for. And the only way to do that is making the absolute value. Okay, so total distance, absolute value. Displacement, no absolute value. Okay, very simple. Part 3, we'll do this in purple. Find the acceleration of particle and see and find if at time t equals 4 is the particle speed, is the speed increasing or decreasing. Let's find the acceleration then. So we know v of t is cosine of pi over 6. So the first thing they ask for acceleration, we need to first find it, right? So always do these steps, even if you don't really know what speed is, maybe you forgot, how to do that, at least write something to try to get points. These guys are going to find ways to give you points. Trust me, guys. You can get a 5 on this because you can find ways to get small points. This is a 9-point FRQ. Trust me, there's a lot of things you can get points on. So v prime of t is the same as a of t, which is the same thing as, so derivative of cosine pi over 6 is going to be negative pi over 6 sine of pi over 6t. And of course, I just did the chain rule in my head. Okay, so now we need to set, so the first thing we need to find is, so we can plug in. So we have v of t and we have a of t. And before we do anything, I need to clarify what the concept here is. Remember, if the speed of a particle is increasing if velocity and acceleration have the same sign. So if v is positive and a is positive, or v is negative and a is negative, increasing speed. Okay, speed is increasing. And if you have, but if velocity is positive and acceleration is negative, or velocity is negative but acceleration is positive, slowing down. Okay, this is really important. These are the two concepts that they're testing you on here. And intuitively, right, that makes sense, because if let's say your velocity is positive, you're running 5 miles per hour, which is not possible, but we're actually 5 miles per hour, and you're speeding up. That means your speed is increasing because you're accelerating more and more and more as you go. It's like an exponential, right? And so it makes sense. And even when your velocity is negative, if you're going in the left direction and you're also you're accelerating less and less and less, your speed is actually increasing. So whenever acceleration and velocity have the same sign, that's when your particle is speeding up. So all we have to do is just find v of 4. And we need to find a of 4, and we need to see, okay, are they both positive? Are they both negative? What's going on here? So v of 4 is equal to cosine of 4 pi over 6, which is actually going to be negative, it's going to be cosine of 2 pi over 3, and that's negative 1 over 2. Now, v of a of 4 is going to be negative pi over 6 sine of pi, 4 pi over 6, which is actually going to be negative root 3 over 12 times pi. And you can do that arithmetic on your own. You can see that both of these are negative, just less than 0, less than 0. So particle is speeding, and I'll write this better actually. Let's rewrite this. Okay, so particle is speeding up since both a of 4 and v of 4 have the same sign. Okay, so this is your solution. Okay, final question. We'll do this one in green. So find the position. Okay, and by the way, these will be, this is a pretty typical velocity, particle motion FRQ. So, if you can do this is a good sign. So we need to find the position at time t equals 4. So first write out what they're asking for. X of 4 is what they're asking for. Now, this is not, so the mistake here is thinking that, if your mind went straight to this is incorrect. This is not true. Because remember what this is giving you. This is going to give you x of 4 minus x of 0. Okay? But we're looking for x of 4. So actually, you need to solve this and rewrite it in terms of x, in terms of these two. So move this x of 0 to the left-hand side. So you're going to get x of 4 is really just x of 0 plus the integral from 0 to 4 of v of t dt, and this is what you need to solve on the right to find x of 4. And just, on a side rate, recall that, f of b is equal to f of a plus the integral from a to b of f of, let's say, x dx. Okay, this is FTC part 2, but it's just rewritten in a way so that you're solving for f of b, given that you know all this other stuff. And remember, they gave you an initial condition for a reason. You're going to, if the AP gives you something like this, you're going to need to use it, right? And this clearly is not, So, okay, so let's solve this, right? So we know up here, remember, we said that x of 0 is negative 2. So x of 4 is really equal to negative 2, right? We can substitute that plus the integral, and I'll write this down actually. So x of 4, sorry, oh my god, is negative 2 plus the integral from 0 to 4 of v of t dt. Okay, so now we need to integrate by hand actually. So this was going to be x of 4 is equal to negative 2 plus integral from 0 to 4 of cosine of pi over 6 t dt. And this is really easy to integrate. You just have to account for the chain. So negative 2 plus, and I'm actually running out of space here. So I'll actually do this down here. So remember, x of 4 is equal to negative 2 plus the integral from 0 to 4 of cosine of pi over 6 t dt. Okay, this is what we need to solve. And from here, it's going to be negative 2 and plus this entire integral Now the integral of cosine of anything is just sine, but we need to multiply by the reciprocal of this fraction to cancel out that chain. So it's going to be 6 over pi sine of pi over 6t. Okay, notice how we got there. Take this derivative, you're going to have a pi over 6 term, and you need to cancel it out. How do you cancel out pi over 6? Multiply it by 6 over pi, the reciprocal. And we're going to do this from 0 to 4. This is really negative 2 plus, and you know, sine of 4 pi over 6 is the sine of 2 pi over 3. So we have sine of 2 pi over 3, and I'm actually going to, I'll bring the 6 over pi out. 6 over pi, hopefully you guys see what I'm doing. Sine of 2 pi over 3, and then it's just 0, so minus 0. So this is really negative 2 plus 6 over pi sine 2 pi over 3. Okay? And you can simply leave it here. You can stop right here. If you do want to continue further, you can obviously simplify this. This will be positive root 3 over 2, so it'll be 6 root 3 over 2 pi. This is negative 2 plus 3 root 3 over pi, and this is your answer. And so we're going to copy this guy and move it up to, let's move it up to here. Okay, so yeah, this is our solution. Okay, so that's what we're looking for. So there's your answer, guys. So this is the answer for part D. So just keep in mind, when you're looking for a position of the particle at a certain time, you're going to need to do more than just integrate. Remember, you're solving for x of 4, not the integral from 0 to 4 of v of t, which is x of 4 minus 0. Okay. All right, there you guys have it. That's a super overly complicated version of this problem. In the real FRQ, you're obviously going to need to take a little bit less time than the time I've taken here to try to explain everything. Realistically, this FRQ specifically should take you one of the shortest times, because the FRQs above here are a lot longer. Not this one, but something like this. This or this especially is going to take a while, but there you guys have it. That's your particle motion FRQ. If you can do this, I promise you're in great shape. Have a great rest of your day.